In this section, we are going to learn about binomial expansion. Before we try to expand a plus b the whole raised to n, let's try to expand a plus b the whole square. How can we expand a plus b the whole square? Yes, we can write it as a plus b times a plus b. Here we can apply the distributive law. The distributive law helps us to expand this as a times a is a square plus a times b is ab plus b times a is ba plus b times b, which is b square. This is equal to a square plus 2 times ab plus b square, because AB is equal to BA. So we can write it as 2 times AB. This is the expansion of A plus B the whole square. Now let's try to expand A plus B the whole cube. We can factorize it into as A plus B times A plus B the whole square. And a plus b the whole square is this. Substituting, we get a square plus 2 times ab plus b square, which is equal to, here we can apply the distributive law. So we get a times a is a cube plus a times 2 times ab is 2 times a square b plus a b square plus b times a square plus b times 2ab, 2ab square plus b times b square, which is b cube. This is equal to a cube plus, here a has power 2 and b has power 1. Here also a has power 2 and b has power 1. So these two are like terms. We can add these two terms. We get 3 times a square b plus, here a has power 1, b has power 2. Here also the same. So adding these two, we get 3 times a b square plus b cube. This is the expansion of a plus b the whole cube. Now, can you see a pattern right here? Here the exponent is 2, a has power 2, and the exponent of a is decreasing by 1. Here it is 2, here it is 1, here it is 0. And the exponent of second term b is increasing by 1. Here it is 0, here it is 1, here it is 2. Similarly, we can see here the exponent is 3, so it starts from 3, then it is decreasing by 1. A has power 3, then it is 2, then 1, then 0. On the other way, the power of b is increasing. Here it is 0, here it is 1, 2 and 3. So, can you write the expansion of a plus b the whole raised to 4 without actually expanding it? Yeah, and we don't know anything about coefficient of these terms. So, leave it be, leave it there. Now, let's try to fill the rest. Here a raised to 4, so here we have here a raised to 4 plus coefficient, we don't know anything about that. Now the power of a is decreasing by 1, so here it is a cube, and the power of b is increasing, b plus the coefficient, then a square, b square plus coefficient, a and b is increased by 1. The power of b is increased by 1, then plus coefficient b raised to 4. Now, what will be the coefficients? For this, we can use Pascal triangle. Now, what is Pascal triangle? Let's see that. Pascal triangle is the construction as it follows. 1, 1. Now, write this 1 down here and add these two ones. We get 2. And put this one right here. Again, 1 is down and 1 plus 2 is 3. 2 plus 1 is 3 and 1 is down. Again 1 is down, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4 and 1 is down. Now we know a plus b the whole square is a square plus 2ab plus b square. Can you see any pattern following here? Like this, in this row, second row. Second row, second exponent, coefficients. Watch coefficients. Here it is 1, here it is 1. Here it is second coefficient is 2 and the term is 2. And the one here is also the coefficient is 1. Now, what about a plus b the whole cube? A plus b the whole cube has, see, a has coefficient 1, here is in this third row, okay, third coefficient means, third power, like a plus b the whole cube, so watch third row, okay, this is the connection. 1 is the coefficient of a cube, 3 is the coefficient of a square b. Again 3 is the coefficient of 3ab square, here is also 3, and 1 is the coefficient of b cube. By this similarity, we can also write coefficients of a plus b the whole raised to 4 that has in his expansion. What is it? Here a raised to 4 has coefficient 1, here is 1, so it is 1. Here the next one is 4. So here the coefficient of a cube b is 4. Here it is 6. The third number is 6. So here the third term has coefficient 6. Remember, the pattern is very applicable only when we write expansion like this. Here the first term has power 4, then it is decreasing. Okay, and the second term has power 0 and it increases by 1. So we can apply this easy trick only when we follow this pattern when we write the expansion. Okay, now here it is 4, so we write here 4 and the 1, here it is 1. This is the expansion of a plus b the whole raised to 4. So we can write the binomial expansion of a plus b the whole raised to n without actually expanding it, without using any distributive law. But this is possible only when the value of n is 4, 5, 6, and we can't use this method when the value of n is very large. So we have to learn how to expand a plus b the whole raised to n, and we will discuss about this in the next video. So thank you. See you later.